Hello, my name is Evan Kuian, and I'm a part of FRC Team 8576 Golden Warrior Robotics, and this is the Programming Basics video, which is a part of our FTC video series. What we'll be learning today is the different ways to program your robot, how to program it in blocks, and how to program it in Java with Android Studio and onboard Java. So there's multiple different ways. First, we have blocks, which is easier to use than Java, but the con is that there's less features and you must be connected to the robot to code it. Next, we have Java, which you can use Android Studio or onboard Java, which I'll talk about later. There's lots of libraries, lots of features, and lots of resources to learn, but it might require a bit more programming knowledge and it's a bit hard to use. There's also Kotlin, which I do not recommend because there's less FTC documentation, there's less support, and it's hard to set up and it's not fully compatible with everything. So now we'll start off with the easiest way, which is programming with blocks. So to set this up, first connect to your control hub Wi-Fi and then type in this number right here in the browser. So for more info to set up your robot, check out the how to set up your robot video in the FTC video series. So once you're on this page, click blocks and click the button called create op mode. So what an op mode is, it's basically just a program, the basic program. So here's the structure of an op mode. So basically, it will run the code from top to bottom, and it'll. So the first block that we see is the one op mode block. It's the purple one on the very outside, and all of that code runs in there. So what that means is when this program is selected, and when it's selected and initialized on the driver station, it will run all the blocks inside. So those first blocks right there, you put the one that says blue and it says put initialization blocks here. Here is where we initialize everything, which is basically everything that needs to be done only once when the robot boots up. The next line of code is the wait for start block right there. So it will wait for the start button to be pressed before moving on to the next if statement. So next is a simple if statement. So basically what it does is if the program name dot up mode is active, which means if the program is actually running, then do the blocks that are inside there. Then we have this block that says repeat while the program is active. So here we put blocks that need to be constantly updated. For example, driving your robot, because you need to consistently read your joystick inputs from your driver controllers to update them and make the robot drive. And then the final block is the call telemetry.update, which is updating the telemetry, which is basically text that will help you debug stuff that you can put onto the driver station, and you do not need it. It's not needed for it to run. So in addition to those blocks of the basic structure, here are some more common blocks that you'll probably need to use. So first we have to call op mode name, which you put the name of your file there, dot sleep, and then you put a double in there, which is milliseconds. So this will delay the entire robot to stop doing everything for how many milliseconds you specified. And just to remind you, 1,000 milliseconds is 1 second. Next, we have the set motor name dot direction, and you set it to a direction. So you choose the motor name that you have, you choose direction, and you tell it what direction you want it to go in. So it will reverse the thing. So it will not move the motor. It'll just tell the robot which direction on the motor, if it's spinning left or right, is actually the forward direction. Then we have the set the motor name dot powered, and here you can set the power to the motor from any number between -1 to 1. +1 makes the robot move forward, while -1 makes it move backward. And 1 is 100% speed, 0.5 would be 50% speed, and so on. Now we'll start learning how to use Java. So Java, there's two ways to use it. You can use onboard Java, which is just like blocks, which you can only access when your computer is connected to the control hub Wi-Fi. And to open it up, you follow the same steps for connecting the blocks, but you click on the button that says onboard Java. But for this tutorial, I'll be using Android Studio, but the coding will be the exact same, except that Android Studio is more advanced and has more features, and you can use GitHub version control, which is a place where you can store your code online, which is very useful. So let's start with GitHub. GitHub is a code hosting website that allows people to work together on the same projects, so you can store your code on the cloud. And if you make a change, you can go back to the previous versions and look at those. So before you go through rest of this tutorial, I recommend basic Java knowledge like classes, objects, and some variables, but it's not very needed. So let's move on to the instructions. So first, we have to create our own repository, which is just a code project. By forking, which means making a copy of the official code provided by First Robotics themselves. But you can also fork the Golden Warrior Robotics repository that we have made for this tutorial, and I've put a bunch of example code in there, and I'll keep it updated with the official code so you won't have any problems. So to make a fork, you click the fork button and you name your new project, and then at the home page of your project, click code. And when you're on the home page, you'll need to click code, copy the web URL that shows up. Next, you have to open up Android Studio. After you install it, of course, follow the install instructions on Google and click the button that says create from version control. Paste in the link from the repository. Next, after it loads up fully, navigate to the team code folder inside of the thing. Open up the motors folder inside of that folder and find a file that says think drive example. And if you run into any problems like minor problems, this will be covered in the troubleshooting video, also in the FTC video series. So here are the pictures on how to do it. Click the fork button, and then after you fork it, you'll end up on your new repository, and you copy the link right there. And after that, you click get from VCS, which is version control system, and you paste in your link. You'll open up a copy of the project onto your laptop, and you can navigate to the folder and find the code. So here's the basic structure for a program. At the top, we import some libraries that we need to use to code the robot. So do not worry about them. Whenever you type stuff up, if there's an error, if you right click on it, it will automatically import those statements for you. Next, we declared at the in the line number 9, where we say at teleop name basic drive, is where we name the file and how it will appear on the driver station and what group it's in the driver station. And then we create our Java class, which extends the linear op mode class, which was created by First Robotics, and you'll need to do this for all of your projects. Next, we create our motor variables and other constants. You can see above that a DC motor, 2 DC motors have been created, and we have not initialized the values, which means that we haven't told the robot which motors these are. These are just some motors, but it doesn't know what motors on the robot they are yet, which we'll say later. Next, we have the at override. It's basically overriding the function. If you know advanced Java, you'll know what this is, but do not worry about it. And we have the public void one op mode function. And inside of there, we put the stuff that needs to be run in while the op mode is active. This is just like the blocks, except it's just in text-based formatting. So now inside of the thing, inside of the one op mode, we see that we declared so we initialize the motors by having left drive is equal to hardware map dot get DC motor dot class, and here you put a name of your motor that you declare it as in the driver station, and this will all be covered in the setting up the robot video in our series. Additionally, we have some telemetry, but in text-based format for Java, and you see them right here. It just tells us that the robot's been initialized, and we update. And next, we have the wait for start function, which waits for the start button to be pressed, just like the wait for start block in blocks programming. So next, we have a while op mode is active loop. So this does is while the program is active, it'll run on all the code inside, just like before. So why we need to run over and over again is when we turn the joystick, when we press buttons, it'll send a signal, and since it's constantly updating, it'll read that signal and calculate the motor power and send out the motor power to make the robot drive. But note that if you want to make an autonomous program, which is when the robot has to move by itself with pre-programmed instructions in the first 30 seconds, you do not need this while op mode is active block, and that will be covered in the autonomous tutorial. So now I'll teach you how to program some simple functions for the motor. So we have the motor.set power parentheses. You put a number here from -1 to 1 and just select the block and it'll set the power. And there's also the dot set direction and you can reverse the directions. So next we'll program a simple tank drive, which is just two wheels on each side or six wheels, and there's only two motors that are controlling it, so it can't move left or right. It's like a normal car, sort of. So we just ran through the initialization and declaring your motors. So first, we'll create these variables that are stored, that will soon store the power that we need to give to the left motor and the power that we need to give to the right motor. Next, we create two Java double variables that store the drive, which is just the y-axis of your controller, and this is for gamepad 1. And we need negative because when you push the joystick up, it actually returns a negative power, but we want it to be positive, right? Because we want to send a positive power to the motors. And for the double turn, we just have it because when you move it to the right, we want it to move to the right, so it's fine. So next, since we now have the drive and turn variables, we will set the power to drive plus turn which for the left motor, because if we move it to the right, the right joystick to the right, it will return a positive value of 1. And if we if we make the left motor go forward with that positive value, it will move to the right, and that's why we do subtract on the right motor, so then the robot will turn. And then we have the range.clip function, which we just put in the first value that we want to give right here, and we can make sure the motor, the variable stay within the intended range, because we don't want it to go outside of -1 and 1 and cause errors. Then at the end, we finally set the power to these motors, and we add some telemetry to tell us what if anything goes wrong and tell us how much power is being supplied to the motors. Thanks for watching this video. You can find all of the code shown in this tutorial on our GitHub page, linked right below. To find it, you just have to go to the theme code folder, then go to src/main, then java/org/firstinspire/ftc/theme code, and open up the motors folder. And while in the GitHub, you can check out the other example code we have linked below. Thank you for watching.